Mars is older than we think, and it shows. Mars carries its age in silence, not in years, but in scars written across an unmoving surface. Long before humanity existed, Mars had already lived through everything we fear. The planet bears the marks of a life fully lived and concluded, a geological biography etched into every crater, valley, and layered cliff. To look at Mars is to witness not a world in decline, but a world that has already declined, that reached its zenith and fell into stillness billions of years ago. The ancient face of Mars tells a story of accelerated aging, of opportunities exhausted, and energy spent long before Earth had even stabilized its own systems. To understand why Mars feels ancient today, we need to rethink how planets age. Mars matters now because it did not simply grow old. It endured. While Earth constantly renews itself through tectonics, oceans, and life, Mars froze in time. Its surface became a memory rather than a cycle. And that difference changes everything. Planetary aging is not uniform across the solar system. Some worlds remain dynamic for billions of years, continuously reshaping themselves. Others, like Mars, experience compressed lifespans where transformative processes occur rapidly then cease, leaving the planet locked into a final state that persists essentially unchanged for eons. Mars exemplifies this latter trajectory, a world that aged too quickly and now exists as a monument to its own past. At first, scientists assumed Mars and Earth shared similar timelines, born together, evolved together, aged together. But closer study revealed something unexpected. Mars matured faster. It burned bright early, then cooled quickly. Its geological clock ran ahead, leaving it stranded in its own past. The evidence accumulated from multiple sources. The heavily cratered southern highlands, showing minimal modification since formation. The timing of volcanic activity concentrated in the planet's early history. The rapid loss of the magnetic field. The swift erosion of the atmosphere. Each line of evidence pointed to the same conclusion. Mars experienced its most dramatic transformations in a geological instant, then settled into quiescence while Earth was still turbulent and evolving. Mars formed quickly, and its internal heat escaped just as fast. Volcanoes once reshaped entire regions, then fell silent. Rivers once carved valleys, then vanished. The planet did not pause. It rushed through its most active phase and entered decline, while Earth was still finding balance. The initial accretion process generated enormous heat, supplemented by radioactive decay in the interior. For a brief period by planetary standards, perhaps the first billion years, this heat drove vigorous geological activity. Massive volcanic complexes formed. Tectonic stresses cracked the surface. Water flowed on the surface, carving channels and pooling in basins. But Mars's relatively small size meant that heat radiated away faster than it could be replenished. The engine driving geological activity wound down, and with it went the processes that could have sustained a habitable environment. This accelerated aging left Mars exposed. Without sustained internal energy, protective systems weakened. The magnetic field faded. The atmosphere thinned. What remained was a planet locked into preservation rather than renewal. The magnetic field's collapse was particularly consequential. Without this protective shield, solar wind directly impacted the upper atmosphere, gradually stripping away lighter elements. Over hundreds of millions of years, the atmosphere that once supported liquid water on the surface thinned to a fraction of its original density. The greenhouse effect weakened. Temperatures plummeted, and any remaining surface water froze or evaporated into space. Mars transitioned from a world that might have supported life to one that could barely sustain it. Mars looks old because it is old in the way ruins are old, not worn down by time, but abandoned by it. Every crater, every dry channel, every layer of rock tells the same story. Mars is not waiting to change. It has already finished changing. The surface preserves a record of ancient catastrophes and gradual declines with extraordinary fidelity. Unlike Earth, where erosion, weathering, and tectonic recycling constantly erase the past, Mars retains features from its earliest epochs. Impact craters billions of years old remain visible, their rims sharp despite eons of exposure. Valley networks carved by water flows preserve their original morphology. Volcanic plains show minimal modification since their formation. Mars is not a living world, but an archaeological site, each feature a fossil of processes long extinct. And that ancient stillness is not just history. It is a key to understanding what Mars became and why its silence matters now. The quietude of Mars is informative precisely because it reflects completion rather than dormancy. This is not a world pausing between episodes of activity, but one that has exhausted its capacity for change. Understanding this distinction matters for multiple reasons. It shapes predictions about Mars's future, informs the search for past life, and provides comparative context for Earth's own geological evolution. That stillness makes Mars feel deceptively simple. A quiet world, a frozen snapshot. But beneath that calm surface lies a record of relentless change compressed into a short planetary lifespan. The simplicity is illusion. Mars's history, when reconstructed, reveals complexity rivaling Earth's, volcanism on a massive scale, flowing water sculpting landscapes, atmospheric dynamics driving weather patterns, possibly even life taking hold in favorable niches. All of this occurred, peaked, and declined within a time frame that Earth would consider merely its infancy. When Mars was young, it was anything but still. Its interior was hot and active. Massive volcanoes poured lava across the surface. The largest mountain in the solar system rose there, not slowly, but through sustained eruptions fed by internal heat. Mars burned through its energy early, spending it faster than Earth ever did. Olympus Mons, towering 21 kilometers above the surrounding plains, represents not patient accumulation, but rapid construction during Mars's volcanic prime. Similarly, the Tharsis Bulge, a massive elevated region supporting multiple enormous volcanoes, formed through intense volcanic activity that would have resurfaced vast areas repeatedly. This was not gentle, steady volcanism, but explosive, transformative activity that remade entire hemispheres. This rapid activity shaped the planet unevenly. Some regions were resurfaced repeatedly, while others remained untouched for billions of years. Unlike Earth, Mars never developed moving plates to recycle its crust. Once activity slowed, the surface stopped renewing itself. Time stopped being erased. The dichotomy between the heavily cratered southern highlands and the relatively smooth northern lowlands reflects this uneven evolution. The northern plains were resurfaced by volcanism and possibly by ancient oceans, erasing earlier impact records. The southern highlands, less affected by later activity, preserve craters from the heavy bombardment period. This preservation creates a temporal mosaic where adjacent regions differ in age by billions of years, a situation impossible on tectonically active Earth, where plate motions eventually recycle all surface material. As internal heat faded, Mars lost its ability to protect what it had built. The magnetic field weakened. Solar radiation began stripping away the atmosphere, not violently, but persistently. With each passing million years, Mars became thinner, colder, quieter. The loss was gradual but inexorable. Without a magnetic dynamo generated by convection in a liquid core, Mars's magnetic field dissipated within its first few 100 million years. This left the atmosphere vulnerable to solar wind erosion, a process that continues today, though at reduced rates now that most volatiles have already been lost. The transformation from a potentially habitable world to the frigid desert we observe today occurred over billions of years, but the trajectory was established early when internal processes could no longer maintain the protective systems necessary for surface habitability. Water followed the same path. Rivers dried. Lakes evaporated. What remained froze underground or escaped into space. Mars transitioned from dynamic to dormant, while Earth was still stabilizing its oceans and climate. Evidence for ancient water on Mars is abundant and compelling. Valley networks resembling terrestrial river systems, layered sedimentary deposits suggesting lake environments, minerals that form only in the presence of liquid water, and geomorphological features consistent with groundwater emergence. Yet all of this is ancient. The most recent evidence for substantial surface water dates to billions of years ago. What water remains exists as subsurface ice or traces of vapor in the thin atmosphere. Mars exhausted its hydrological cycle before Earth's oceans had even fully formed. This is why Mars feels older than its age suggests. Its most important changes happened early and fast. The rest of its history has been preservation, not evolution. Earth looks young because it never stopped changing. Mars looks ancient because it did. The contrast is stark. Earth at 4.5 billion years old remains geologically active with ongoing volcanism, mountain building, and crustal recycling. Mars at the same age is geologically moribund. Its major processes shut down billions of years ago. Age measured in years is identical. Age measured in evolutionary trajectory is vastly different. Every layer of Martian rock is exposed, uninterrupted by renewal. Billions of years lie open to inspection. Mars does not hide its past. It cannot. This transparency makes Mars invaluable for planetary science. The surface functions as a natural stratigraphic column where different epochs remain accessible to observation and sampling. Missions can study ancient terrains without drilling kilometers into the crust as would be necessary on Earth. The geological history is written plainly across the landscape for anyone with eyes or cameras to read. And in that exposed history, Mars reveals what happens when a world ages too quickly and has nothing left to spend. The lesson is sobering. Mars demonstrates that planetary habitability is not guaranteed by position in a habitable zone or initial endowment of water and atmosphere. Sustained habitability requires ongoing geological activity to recycle materials, replenish atmospheres, and maintain protective magnetic fields. Mars had these systems briefly, then lost them. The consequences were irreversible. The conflict in Mars's age lies in what it teaches about planetary survival. Aging is not just about time passing. It is about how energy is managed while time passes. Mars used its energy early and left little for later. The planet's small size, roughly half Earth's diameter and 1/10 its mass, meant limited initial heat from accretion and a higher surface-to-volume ratio that accelerated cooling. These fundamental physical constraints determined Mars's fate more than any contingent events. The planet was destined by its dimensions to age rapidly. Planets survive through balance. Heat must circulate. Atmospheres must be replenished. Protective fields must persist. Mars lost that balance quickly. And once lost, there was no mechanism to restore it. The cascading failures were interconnected. Loss of internal heat led to loss of magnetic field, which enabled atmospheric erosion, which eliminated surface water, which precluded any geological processes dependent on water. Each failure amplified the next, driving Mars inexorably toward its current state. There was no recovery, no second chance, no way to restart systems once they had shut down. This challenges a comforting assumption. That time alone determines a planet's fate. Mars shows that pace matters more. A world can be young in years and old in consequence. It can burn brightly, then fade long before its time. The chronological age and evolutionary age need not align. Mars proves that rapid aging is possible, that a planet can exhaust its potential in a fraction of its expected lifespan. This has profound implications for assessing exoplanets. Time since formation matters less than current geological activity. Earth avoided this fate by chance and structure. Its size retained heat longer. Its moving plates recycle material. Its magnetic field endured. Mars had none of these advantages long enough to sustain itself. The contrast illustrates how seemingly minor differences in initial conditions, primarily planetary mass, can determine entirely different evolutionary paths. Earth was fortunate. Mars was not. The difference is that simple and that consequential. The conflict emerges when we consider inevitability. Was Mars always doomed by its size and composition? Or could different conditions have prolonged its vitality? Mars does not answer that question directly. It only shows the outcome. Perhaps Mars never had a chance. Its fate sealed by formation in a region where insufficient mass accreted. Or perhaps contingent events accelerated the inevitable, pushing Mars towards stillness faster than necessary. The question remains open, but the result is unambiguous. This uncertainty forces a broader reflection. Survival is not guaranteed by origin. It is maintained by continuity. Mars lost continuity early. And once that thread broke, decline followed naturally. The insight applies beyond planetary science. Any complex system requires ongoing inputs to maintain organization against entropy. Mars lost those inputs when its geological activity ceased. From that point, decay was guaranteed even if gradual. The lesson is uncomfortable. Longevity depends less on beginnings and more on endurance. Mars reminds us that running out of energy is not dramatic. It is final. There are no second acts, no Phoenix-like resurrections. Once fundamental processes shut down, they do not spontaneously restart. Mars will never again see rivers flow or volcanoes erupt. Its story is finished, written into stone and ice for whatever duration the universe permits the planet to persist. And that finality defines everything we see today. The climax of Mars's age is the realization that it did not grow old slowly. It aged all at once, early in its life, and then remained frozen in the outcome of that loss. What we see today is not decay in progress, but decay completed. Mars is not dying. It is dead, geologically speaking, and has been for billions of years. The distinction matters because it clarifies expectations. We should not anticipate reawakening, but should recognize that Mars represents an endpoint, a final state that will persist essentially unchanged for the remainder of the solar system's existence. Mars reached its limits long before anyone was there to witness it. Once its internal energy faded and its protections collapsed, time stopped shaping it. The planet entered a state of permanence. Not stability, but stasis. Nothing cycles back. Nothing heals. The surface modifications that do occur, small impacts, erosion by wind, seasonal frost deposition, are superficial, leaving no mark on the planet's fundamental character. Mars is locked into its current configuration by the absence of driving forces that could reshape it. The resolution of this story is written across the surface. Mars is a reminder that survival is not about how long something exists, but how long it can sustain change. Earth renews itself constantly. Mars cannot, and that difference defines their futures. Earth will continue evolving for billions of years until the sun's transformation into a red giant renders further change moot. Mars has already reached its endpoint, a final configuration that will persist largely unchanged. The futures diverge because the presents differ. Earth remains active, Mars does not. Mars shows us that age is not measured in years, but in options. When options disappear, aging accelerates. And when renewal ends, history becomes fixed. This perspective transforms how we understand planetary evolution. Age is not chronology, but capacity. The range of possible futures, the potential for continued change. By this measure, Mars is ancient indeed. Mars will remain ancient forever. Not because time keeps passing, but because nothing new can replace what was lost. Its silence is the sound of a planet that has already finished becoming what it will always be. Barring external intervention, terraforming, for instance, Mars's fundamental character is permanent. The ancient world we observe today is the world that will exist as long as Mars exists. Subscribe to join the journey. Mars